So hey, that was the end of section 1. Oh, I forgot to turn on the baby monitor. Let's hope the baby doesn't cry. So now we're going to go on to section 2, the calculator. So let's get our calculator out, well, I better go get my calculator. I'll be right back. All right, here it is. The TI-83 plus. This thing is classic. Okay, so the amount that 2 plumbers charge for their services are described. The first plumber charges a fixed fee of $40 and $15 per hour of work. So, when I read that, first thing that I'm thinking is we have slope-intercept information. Do you remember slope-intercept? Y equals mx plus b. That's all you need to know. All right. You can graph a line. You'll be just fine if you remember the slope and the y-intercept. All right. So we got that. So the slope is always the per hour. It's a very good indicator. Sometimes they try to trick you, but so this is the slope of a slope-intercept equation. And this is the y-intercept. So we know we have the one line is y equals 15x plus 40. Now, I haven't even read the whole problem, but I just want you to see the things that I'm thinking about as a math teacher. You should be thinking the same things as a math student taking this test. So now we can see the second line has the same wording, just different numbers. So it's going to be 19x plus 30. Now, there we go. Okay, for what number of hours will they do the same amount? Guess what? That's a system of equations. In a system of equations, we want to know the forms of the lines, so we know they're in slope-intercept. And if they're both in slope-intercept, we set them equal to each other, the mx plus b parts. If only one of them was in slope-intercept, we would take that mx plus b part and substitute it into the other equation, usually in standard form. Okay, so what we're going to do is we're going to write 15x plus 40 equals 19x plus 30. And hey, we can use a calculator, but I don't really need one yet. What I like to do is I put my variables on the left. So 15x is already in the left. 19x has to go over to the left. So on the left side, it will be negative 19x. 30 is already on the right. 40, oh, so I put my variables on the left, numbers on the right. And the 40 has to go over to the right. So it's going to become negative 40 on the other side. Normally we say subtract 40 from both sides, subtract 19x from both sides, but I like to do it in this one quick step. So now 15 minus 19 is 4, negative 4. And 30 minus 40 is negative 10. So now we got negative 4x equals negative 10. Divide both sides by negative 4. X equals negative 10 over 4. Well, I know what that is, 2.5. Calculator, 2.5. So for what number of hours of work? 2.5 hours. Now, it is important. One thing I didn't do is define my variables. So we see that it's $15 per hour. So whenever you have the slope, the word after per is the x, and then the other unit is the y. So in this case, dollars. So we can say, let's add this, x is hours of work, and y is dollars that the plumber made. Okay, so that's good for that. Number 2, consider the function defined by y equals 2x minus 5. So you can see the slope-intercept form Just popped up in two equations. Do you think it's important? Because I do. Which statement can be used to justify if the function is linear? Well, I know it's linear because it's in slope-intercept form and it has a slope. So I'm going to look for the choice that talks about this thing as a slope. Coefficient of x, no. The function has a constant slope. That's it. The function has negative y-intercept. No, that's not it. The graph of the function is a straight line. Oh, that's also true. That's why we know it's linear. Linear means line. The equation is written in the form y equals mx plus b. That is what I said at the very beginning. So I would choose B, D, and E. All right. Any questions? All right, moving on. Number 3. What? I keep losing my mouse. A person purchased 10 items to donate to a school. Backpacks that cost $25.75 each. Notebooks that cost, so that's a slope word again, that each. Notebooks that cost $4.25 each. The total cost of the items is $150. So another way to think about that each is coefficient. All right. So you notice that the slope is a coefficient. You know what a coefficient is? It's a number next to a variable, right? And that's what a slope is. And so they gave us notebooks and they gave us backpacks. So what we could do is we can call one of those X, the other one Y, because I think we're looking for a system of equations, right? And 10 items to donate to the school, backpacks and notebooks, right? So we have 10 total items, and there are two kinds of items: backpacks and Y is notebooks. So they did, it's a little sneaky, but they gave us enough information to create two systems of equations. The first is that we have 10 items, backpacks plus notebooks, and we want to donate 10 total. We can donate more of one equal 5 of both of them. I will be right back. One equation can represent the number of items all right, because they told us a total number of items. That's another thing. The totals go on the other side. So what other information do we have? Total, we have cost, right? We know the total cost is $150. And how much do the backpacks cost? $27.75. So write that like that. How much do the notebooks cost? $4.25. $4.20. Oh, I did not give myself enough room to write those numbers. So 27.75x plus 4.25y. And now we want to know what does the solution of the system represent in this context? The cost of the backpacks, the cost, total amount of money, the number of backpacks. So the solution is going to be X backpacks and Y notebooks. So it's the number of backpacks and notebooks purchased, because that's what the variables represent. So you remember in the problem above when I didn't define my variables. That's why that's important. You don't want to solve a system and then not know what the answer is. Okay, on the following, oh, and if we did want to solve that system, I would have taken the x plus y equation and put it in slope-intercept form so I could substitute it. That's what I would have done. On the following coordinate grid, points N, P, R, and T are collinear. That means they all are in the same line. The coordinates of each point are integers. That means no decimals. The dashed lines shown on the coordinate grid form triangles MNP and QRT. Okay. Linda claimed that the slope of PR is 6/4 because P is 6 units to the left of R and 4 units up from point R. Explain Linda's error and calculate the correct slope. Sorry, Linda, you did it wrong. So, okay, so she said the slope of PR is 6/4. So now I'm going to calculate the slope of PR myself. So P to A, do you know the slope formula? Y2 minus Y1 over X2 minus X1. We're going to calculate it with P and R. So P is at -3, 3. R is at 1, 2, 3, -1. Okay, so Y2 minus, so now I'm going to label my points. This is X1, Y1. Don't put X1, X2. This is X2, Y2. And now I'm going to substitute. Y2 minus Y1 is -1 minus 3. Y. And that's over X2 minus X1. So 3 minus -3. And we know we have some integers. So -1 minus 3 is -4. Add them together and your answer is negative. And then 2 negatives in a row make a plus sign. So that's 6. Okay, let me pause the video. Okay, so I see a couple things that Linda did wrong. First of all, she put her X's over her Y. She did, first of all, her run is over her rise. That's not good. You know, it's rise over run, right? Everyone knows that. Rise over run. That is the slope. That means the Y, change in Y over change in X. Second thing Linda did is she has a positive slope, but we see the line is going down from left to right. So it's negative. So there's 2 errors there. Explain the error, calculate the correct, show all of your work. And there it is. This is a 2-part. Use a triangle to show the slope of the line is the same from N to point P and from R to T. N to P, R to T. So if I want to show the slope is the same, then, and use the triangles, what we could do is we could just label the sides. So that's 2, 1, 2, 3, that's 3. This is 1, 2, 3, 4, that's 4. 1, 2, 3, 4, 5, 6. Why won't write 6? All right. Okay, so then we know it's rise over run and also negative. And then, so then we can just say divide that by 2, and because you can, and then it's -2 over 3. And they're equal. So you could just label the sides of the triangle and show that. But you see, Linda should have used the slope formula, even though they gave us those triangles, because it helped me not make that negative mistake. All right. So now the figure shows the front side of a store sign and its dimensions in feet. What is the area in square feet of the sign? Oh, you can do that. The area of the sign, what's a trapezoid? But it's also a rectangle and a triangle. So the top of this rectangle is 3, the bottom is 3. And if that much is 3 and the whole thing is 6, that must be 3 too, because 3 plus 3 is 6. And to find the area of this triangle, I need the height of the triangle, because the area of a triangle is 1/2 base times height. And the area of a rectangle is base times height. I know, and I need that height. But don't worry, because this is not just any triangle, it's a right triangle. So I can do a quick little Pythagorean theorem here. A squared plus b squared equals c squared. And my a is going to be 3, my b is unknown, and my c is 5. Always across from the right angle that c is. So I'm going to substitute that in. A is 3, unknown b. Now I'm going to square my numbers. 9 plus b squared equals 5 squared is 25. Now I'm going to put that 9 on the other side as a -9. B squared equals 16. Do not divide by 2 at this point. I told you that earlier in the test. Square root both sides. Sorry if I scared someone. So B is 4. So that means this is 4. You see that? It's 4. It's no longer X. No longer B. It's 4. So that really helps us out a lot. So now we know the height is 4, base is 3 for the rectangle, and the base is, it's also 3 for the triangle. So we can do that. We know it's 3 times 4 for the rectangle, which is 12, plus the area of the triangle. It's 1/2 3 times 4, which is 12 times a half, which is 6. 12 plus 6 is 18. Composite area. So when in doubt, separate your figure into triangles and rectangles and use the area formulas. Certain values of linear function j are shown in the following table, where x is the input variable and y is the output variable. Linear function k is represented by the equation 3x plus 8, which, okay, so let's compare. And let's talk about the representations of functions. I like to say them as the word get. Can you remember that? Get. This is the representations of functions acronym I personally created. Get. Get stands for graph, equations, tables. All right, we could graph that line, we see the table and the equation, and we can always do all three for, given one, you can do the other two. So right here, I'm going to find the slope-intercept form for this table. And I know that this first point has an x value of 0. So that means it's the y-intercept. You should know that at the x-intercept, the y is 0, and the y-intercept, the x, is 0. So that's the y-intercept. So I know that b is 2. So now I just need to know the slope, the mx plus b. So we look in the table, the change in x is 1 and the change in y is 5. So the slope is rise over run, it's 5 over 1 or just 5. So the table is represented by the equation 5x plus 2. Okay, now we can easily answer any question comparing them when they're in the same form. And this is function k, and this is function j. All right. So function j has a greater slope. Yes. It's 5 is greater than the slope of 3. Function k is the greater slope. Now, Function J has a greater y-intercept. Let's look at the y-intercepts. No. Function K has a greater y-intercept. Yes, because 8 is greater than 2. So yeah, A is right, D is right. The graph of function K and have equal slopes. No. Equal. So this was a really easy question now that we had them in the same form. So I encourage you to get those in the same form. All right, moving right along. Triangle PRT and triangle QRS are shown on the coordinate plane. Points P, Q, and R all lie in the same line, and points T, S, and R all lie on the y-axis. The vertices of both triangles have integer coordinates, no decimals. All right, which statement about the slopes is true? Okay, slopes. So I can already see that we have 2 0 slopes, Q and S, PT, and then the slope of these diagonal lines are the same, and then the vertical line. So PR and QR are equal. PR and QR are equal because, oh, PR and QR are equal because the slope of PR is less than QR. No, they're the same. Okay, so we know the slopes are equal because they're on a straight line together, you know? So we already know that C and D are not right. So now let's think about our slope triangle. Remember how we did that in the question earlier? So we have our rise and our run. So to find the slope of QR, we would take the rise, RS, and divide it by the run, QS. To find the slope of PQ, oh, PR, sorry, PR, makes it even easier. We'd find the rise would be RT, and the run would be PT. So which one of these says RS over TR? So RS over SQ. Okay, that's close enough. That one works. And then TRTP, TRTP. Okay. So they wrote it backwards from what I wrote it, but that's okay. B is still the correct answer. You see that? Slope triangle. Oh, stop. All right, I'm gonna stop this video and then start recording the next video.